Hello everyone. Today let's start paper 1, paper code 9709, variant 2, May June 2023. Let's begin. Okay, the question 1 says that the equation of a curve is such that dy by dx is equals to 4 over x minus 3 whole cube for x is greater than 3. The curve passes through the point 4, 5. Find the equation of the curve. Okay, so we know that if we are given dy by dx, we can find the equation of the curve by integrating this derivative. Okay, so integrating the right hand side, 4 over x minus 3 whole cube dx. Actually, we are not integrating just right hand side, we are actually integrating the both sides. But firstly, we take this dx to the right hand side, we integrate both sides. So integrating with respect to dy 1, like 1 with respect to dy, it will give you y. But in short, we say that we are integrating just right hand side. Okay, so first write this in the simplest form. X minus 3 with in numerator with power minus 3 dx equals to 4 on the outside. Because it's a constant, we can take it outside and we can apply the integration of like the power rule that says if you have the derivative multiplied with it, derivative of the bracket, what we can do is we can simply do x power n plus 1 over n plus 1. Yes, so we are doing the same. We are writing it x minus 3 power minus 3 plus 1 over minus 3 plus 1 plus the constant of integration. Okay, so simplify this. Power minus 2 plus c. This will become minus 2 and 4 will be cancelled out, so this will become minus 2. This minus in the denominator will be adjusted over there, and you can write it as minus 2 over x minus 3 power 2. Okay, plus c. Okay, how can we find now the constant of integration? We are being given that this curve passes through the point. So if we know the coordinates, we can put the values of x and y coordinate in the equation and we'll get the c. So x is 4 and y is 5. So simplifying this further, minus 2 plus c 5. C is equals to 7. So your equation of curve is y is equals to minus 2 over x minus 3 whole square plus 7. Okay, question 2. Question 2 says the coefficient of x4 in the expansion of x plus 8 whole power 6 is b, and the coefficient of x square in the expansion of ax plus 3 power 4 is q. It is given that p plus q is equals to 276. Find the possible values of the constant a. Okay, so they have given you the coefficient of x4 is p in this expansion. The second thing have given you is the coefficient of x square in the expansion of this is q, and also they have given you the relation between them. So first we will do the expansion. Either you can find this term or the coefficient of x4 by expanding this, or you can find it by using the term equation, and we will do it by using a term equation that is very much accurate and short method. So that is T r plus 1 is equals to NCR A n minus r b power r. Okay, so let's start for applying this for your first expansion. So Tr plus 1 is equals to n is 6cr, a is x, power n minus r, so 6 minus r, and b is r, and a is r. Okay, taking out x, it is already separate, so you can simply first let's just open these brackets. So, and now equate the x power 4 equal to the x power in this equation that we get. Okay, x is power 6 minus r, so that implies that 6 minus r is equals to 4, or 4 is equals to 6 minus r, and r is equals to 6 minus 4, that is 2. So that means by putting r equals to 2 in the above equation will give us the term with the x power 4. Okay, so applying this, t r plus 1 will be 3 is equals to 6c 2 x power 6 minus 2 a power 2. It's 15 x power 4 a power 2. So the coefficient of x power 4 is 15a square. This is it. Now let me just arrange this a bit. And now on the right hand side, I'm doing the second expansion. Okay, so the second expansion is ax plus 3 power 4. So tr plus 1 is equals to n is 4, 4cr, a is ax, 4 minus r, and b is 3 power r. So let's take out x from x with the power. So this is going to be 4cr a power 4 minus r, x power 4 minus r, and 3 power r. Okay, putting a dots because all of these are being multiplied. So in this equation, this is your equation from which we got we are going to equate it to the power x power 2. Okay, and then after getting r, we are going to put it in this equation. So x power 2 is the required term that we want, and we are going to put it equals to x power 4 minus r. Okay, so this is going to give us 2 is equals to 4 minus r, and r is going to be equals to 4 minus 2 is equals to 2. So again we got r equals to 2, but the term and the expansion is different. So let's put it in the above tr plus 1, and that is in this case would be t2 plus 1, that is 3. 4c2 a power 4 minus 2 x power 4 minus 2 and 3 power r, 3 power 2. Sorry, I have written 3r over here instead of 3 power r. Okay, so also just write this a bit clear. Okay, that's it. Now t3 is equals to 4c2. So 4c2 is going to be, it's going to be 6, I guess. So this is 6 a power 2 x power 2 and 3 square is going to be 9. So simplifying this further will give you 54 a square. So this is your coefficient of x square in the second expansion. Okay, so let's just try to arrange this a bit. Okay, so now we have to find a constant a, and for that we are being given a relation that is p plus q is equals to 276. So here it is p plus q is equals to 276, and what is p and q? They told you that the coefficient of x4 is p and the coefficient of x square is q. So here it is, this is p and here it is q is equals to 54 a square. Okay, so let's add them. 15a square plus 54a square is equals to 276. So 54 plus 15 is going to be 69a square is equals to 276, and a square is going to be equals to 276 over 69. So this will give you, I guess, 4. 4, and then a is going to be equals to plus minus 2. So find the possible values of constant a. They haven't said any one particular value, positive value of a, or they haven't given any other condition. They just said find the possible values of a. So the possible values of a are plus minus 2. Okay, so this is your whole working of this question. That's it. Okay, so now question 3. Question 3 says express 4x square minus 24x plus p in the form completed square form, ax plus b whole square plus c, where a and b are integers and c is to be given in terms of the constant b. Okay, so let's solve it. First, how do we change it an equation into a completed square form? In the first step, we take out the constant that is being multiplied with the x square. So we are going to take that common. X square minus 6x plus p by 4 . Okay, next what are we supposed to do? We are going to complete the square, and for that what do? Whatever is being multiplied with this x, we half it and we add and subtract its square. Yes, so its half is 3, so we are going to add and subtract the 3 squared, and first write this back. Plus p by 4 will come as it is. Okay, next we'll do write it as a completed square. X minus 3 whole square minus 9 plus p by 4. Now what are we supposed to do? We will multiply this 4 inside the bracket with all the terms. As we know, the standard form is, like completed square form is ax plus b whole square plus c. Okay, so let's do this. It will become 4 times x minus 3 whole square minus 4 9s are 36 plus p. This 4 and 4 will be cancelled out. Okay, in the next step, now arrange this a bit. 4 into x minus 3 whole square plus p minus 36. Now this is our simplified form, but what do we need? We need c to be given in terms of p. Okay, and for that, first identify a, b and c. So from the, if you compare these two, you'll get to know that a is equals to 4, b is equals to minus 3, as here b is plus b and here it is b is equals to minus 3. Okay, I hope you get it. Like in the normal completed square form, the b is positive, but here it is negative, so it means that b, there is a negative sign with the number that is equals to b. Okay, third, c is going to be p minus 36. Okay, so this is all that we have. Okay, so part B now. Hence or otherwise, find the set of values of p for which the equation 4x square minus 24x plus p is equals to 0 has no real roots. Okay, so we know that for the imaginary roots or no real roots, what is the relation that we have, or what is the value of the discriminant? Our discriminant b square minus 4ac is smaller than 0. Okay, so first let's try doing it with this method. There are multiple methods, as they have said that hence or otherwise means you can either find it through using this relation or this form of equation, that is your completed square form, or you can find it otherwise. That means that you can find it by using your original quadratic equation. So let's try doing both the ways. First we are trying to do it using your quadratic equation. So see what is b over here. This is the form ax square plus bx plus c. Okay, so a is 4, c is p, and b over here is minus 24. This is going to be smaller than 0. Sorry for writing it like not going from b square. I have started from a and then I wrote the value of c and then I wrote b. Okay, but it doesn't matter. So 24 square. So this is going to give you 576 minus 16p is smaller than 0. Then shifting this 16p to the other side of the equation, this will become positive 16p and 576 over here. So this will give you p is greater than 576 over 16. When you will do it on the calculator, you will get p is greater than 36. Okay, so this is the first way to find the solution. We get that the set of values that are greater than 36, this equation has no real roots. Okay, now let me just arrange this a bit for you, and let's do this second way of doing it. I'm drawing a line over here. Okay, the second way is that we know, okay, for doing it from the second method, we are going to use the completed square form, this one. Okay, and this completed square form, the value of a suggests that it is going to be a minimum point because it is positive. Okay, so let's first find out the minimum point. We know the x coordinate is whatever in the bracket is, you put it equals to 0. Okay, yes, for example, here you are going to put x minus 3 equals to 0, and you will get x equals to 3 as your x coordinate, and this p minus 36 is going to be your y coordinate of the minimum point. So just write it down in place of that. This is going to be 3 and p minus 36. Now using this information, roughly draw a sketch of your graph. For example, this is your 3 point and this is your p minus 36. So this is going to be your curve. Okay, or let's draw this a bit below because we don't know what is p minus 36. So by plotting this, okay, from this information we can infer that we know that in the question they have given you there that
this equation has no real roots. If there are no real roots, that means there is no point of intersection, because for the imaginary roots, this curve is not going to intersect your x-axis. Okay, so that means if this is 0, okay, so that means that your p minus 36, this point, turning point, is not going to be smaller than 0. It should always be greater than 0, because there will not be any point of intersection. As I already said, that in case of an imaginary roots, the curve is not going to intersect the x-axis. Okay, so from this we can clearly infer that p is greater than 36. The same information or the same solution we are getting from this completed square form. So this is all about your part B. You can see this whole question for a while. Question 3. Now let's move on to question 4. By looking on the front, you can think that this is not a quadratic because x has the power 6. But if you see the sequence, first you have the power 6, and in the second term you have the power 3, and then you have a constant term. Okay, the same happens in a quadratic equation, x squared, then half the power in the second term, and then you have a constant term. So it is quadratic, but it is quadratic in x cube, not x. Okay, so make it simple. We can do the substitution, or we can do it directly, but it will be complicated for you. So it is better to make it use the substitution and make it quadratic in some other variable and then solve it. So let's consider that x cube is equals to t. Okay, so it will become 8x, sorry, not x now, 8t square, now because x cube is equals to t, plus 215t minus 27 equals to 0. Now this is quadratic in t. Now we can break the middle term. 27 times 8 will give you 216, I guess. Okay, minus 216. So by multiplying we should get minus 216, and by adding or subtracting we should get plus 215. So this is simple. You can simply do it like 216t minus t, when multiplied will give you minus 216t. Sorry, here should be 216t minus t. Okay, it will give you, when multiplied will give you a minus 216t, and when added or subtracted it will give you 215t. So this is how we break the middle term. Maybe you use some other method, but this suits me best. So now simplify this. 8t taking common, t minus 27, as we see in the start as well, that 27 times 8 is 216. So 8t out will give you t minus 27, sorry, t plus 27, and minus 1 will give you t plus 27. Okay, now take out the values of t from here. T 8t minus 1 equals to 0, that will give you t equals to 1 by 8, and t plus 27 equals to 0 will give you t is equals to minus 27. Now substitute back t is equals to x cube. So x cube is equals to 1 by 8 and x cube is equals to minus 27. Now taking cube root on both sides for both the values, so it will give you x is equals to 1 by 2, as 8 is a cube root of 2 is a cube root of 8, and x is equals to minus 3, as 3 is a cube root of 27. Okay, so this is it. You get two values, 1 by 2 and minus 3. So here it is solved. Now question 5. Okay, so the diagram shows the curve with equation this for x is greater than 0. The curve meets the x-axis at points 0, 0 and 4, 0. Find the area of the shaded region. We know the area of the shaded region is the area under the curve, and we find it by integrating between the limits, and we see that it is between 0 and 4. Okay, so integrating this, zero to 4, 10x to the power of 1 by 2 minus 5 by 2 x to the power of 3 by 2 d of x. Okay, so taking this 10 x to the power of 1 by 2 dx minus 5 by 2. I am separating the integration just to make it simple, because we have like the constant terms that we don't need to be multiplied during the integration. So that is why I'm doing this. You can do it as a whole as well. So we know that the integration of x to the power of something will be x to the power n plus 1. Here this is going to be 1 by 2 plus 1 and 1 by 2 plus 1 between the limits 0 to 4 minus 5 by 2 and x to the power of 3 by 2 plus 1 over 3 by 2 plus 1. Okay, now simplifying this from the limit 0 to 4. Okay, x power 3 by 2 over 3 by 2. Five by 2 and 2. Actually, we should carry on with the same line brackets modulus 5 by 2 into x to the power of 5 by 2 over 5 by 2. Okay, then we have 10 into 2 by 3. I am doing it in a lengthy way. You can directly do the integration together and then apply the limits. And then we'll apply x to the power 3 by 2 with the power 4 and 0 limits, and 5 by 2 multiplied by 2 by 5 x to the power of 5 by 2 between the limits. Okay, so this will reduce this to 20 by 3. Now I am applying the limits. 4 to the power of 3 by 2 minus 0 minus this all will cancel out. So 4 to the power of 5 by 2 minus 0. So this will give you 20 by 3. 3 by 2 minus 4, 5 by 2. Sorry, this is just 20 by 3 is just being multiplied with the first term, not with the second one. So this will become 8 and this will become 32. So 20 times 8 is going to be, just let me arrange this a bit. Okay, so this will give you 60 to the 16. 160 by 3 minus 32. It will be 160 minus 96 by 3, and that will give you 64 by 3. Okay. So that's it. I'm also reducing it to match the size of the original one. This is all. So this is how we can find the area of the shaded region.
Okay, so now question 6. The diagram shows a sector OAB of a circle with center O. Angle AOB is equals to theta radians and OP is equals to AP. That is this x is equals to this x. Show that the arc length AB is 2x theta cos theta. Okay, so we know that arc length is equals to r theta. We know this theta is theta over here, and r is OA or OB, so we have to find that OA. To find that, there are multiple ways of doing it, but what we suggest is do like this. Okay, so if we draw perpendicular from P to OA, so we get this into two equal parts. Let's call it point S. So OS is equals to AS And how can we find it? This is a right angle triangle, so we can think of it as, let's see if this is your base and this is hypotenuse. So which trigonometric ratio relates these two? Cos theta. Cos theta is equals to OS over X. Okay, so this OS is equals to X cos theta. Okay, and we know that OA is equals to 2 times of OS. OA is equals to 2 times AS. Sorry, OS. So this will become, this R will become 2 times X cos theta. So here we will write 2 times X cos theta times theta. This will become 2x theta cos theta. Now, part B. Part B says find the area of the shaded region APB in terms of x and theta. APB. This is your shaded region. So, how can we find it? We can find the area of the whole sector and we can subtract this triangle OPA, this triangle from the whole sector, so we will get the area of the shaded region. So first let's find the area of the sector. Area of sector OAB is going to be equals to half r square theta. We know r now. R is OA, so and OA is 2x cos theta. So half time 2x cos theta square theta. So this will become half of 4 times x square cos square theta 2 2s are 4, 2 x square theta cos square theta. So now the area of triangle OPA. So we know this is going to be half base into height. Base is OA and height is SP or PS. OA into PS. OA into PS. You know OA but you don't know PS. So to find out that, let's look into the figure. If this is your height, so how can you find it? Height is equal height, which quantity relates height and hypotenuse? So height is perpendicular over here, so perpendicular over hypotenuse is equals to sine theta. Okay, and so that means that height is going to be equal to x sine theta, or you can say PS is equals to x sine theta. Okay, x sine theta. half of OA. Let's just first arrange this a bit. OA is 2x cos theta. And PS is what we just found, x sine theta. So 2 and 2 will be cancelled. You will get x square sine theta cos theta. So we found the area of both, and what we'll do now is we'll find the area of the shaded region. Is equals to area of sector minus area of triangle. Area of sector is 2x square theta cos theta minus x square sine theta cos theta. And you can take something common and simplify this further, or you can leave it as it is. So we can take x square and cos theta common. So x square cos theta, this here will be left 2 times theta minus sine theta. So this is your whole working of part B and A both. Here is a letter error, a mistake. If you can identify, here it was cos square theta. So here also will be cos square theta, and then this last step will be changed a bit. X square cos theta will be taken common, so we will be left with 2 times theta cos theta minus sine theta. This is it. This is your final solution. Now let's move on to the next question, question 7. I have already solved it. There is a reason behind it. See this whole solution. It is very, like, we have to write a lot of steps and a lot of terms, and doing this all needs more time and arrangement. So that's why I have done it already, so we can go through it quickly. Okay, so let's start with this question 7 from here. I'll tell you step by step. By first expanding cos theta plus sine theta whole square, find the 3 solutions of the equation. Okay, so cos theta plus sine theta whole square is equals to 1 is your required, is your given thing. Okay, so and the range is also being given. So first try to expand it. A plus b whole square form. So a square plus b square plus 2ab is equals to 1. Then we'll arrange this in the brackets, and we know that cos square theta plus sine square theta is equals to 1. So this will be equals to 1, and here we will be left with just 2 sine theta cos theta, because 1 here and 1 here will be cancelled out, or this means that 1 over here will go on the other side and it will become minus 1. So 1 minus 1 will be equals to 0. Now after this we are left with sine theta cos theta, because 2 also when divided on the other side of the equation will give you 0. So this implies that either sine theta is equals to 0 or cos theta is equals to 0. So putting this both equals to 0 and consider your given range from 0 to pi, that means in the first two quadrants. So sine theta is 0, we know at 0 and pi, so we don't need to find the angle, we just know it from the table as well, that the whole values of at 0, and cos theta is 0 at pi by 2 and minus pi by 2, or you can call it as 3 pi by 2. But we are going to reject this one because this is not going to come in our range. So we have three solutions, as they said in the question, that find the three solutions. So these are 0, pi and pi by 2. So look at this. I hope you'll understand this. Now let's move on to the part B. Hence, verify that the only solutions of the equation for the given range are 0 and pi by 2. Okay, now see, first they have given you cos theta plus sine theta whole square is equals to 1. If they are now just considering one thing equals to 1, that means the single cos theta plus sine theta. So for that, they are telling you that for this part of this original equation, there are just two solutions, 0 and pi by 2. Okay, so how can we verify that? You are going to put all the three solutions that we found in the previous part 1 in the given equation, this one that is now given to you, and we will verify if left hand side is equals to right hand side, then it is verified that these two solutions are valid, and for the solution for the angle for which this is not valid will not be equal. I hope you get it. Okay, so let's start from theta is equals to 0. So cos 0 plus sine 0, cos 0 is equals to 1, sine 0 is 0. So left hand side is equals to right hand side, hence proof that theta is equals to 0 is a solution. Now put pi by 2, cos pi by 2 is 0 and psi pi by 2 is 1. So this also proves that left hand side is equals to right hand side. So pi by 2 is also a solution. Now putting theta is equals to pi will give you cos pi is minus 1 and sine pi is 0. So this tells us the left hand side is not equals to right hand side, and that is why theta is equals to pi is not the solution of your cos theta plus sine theta equals to 1. I hope you get it. Now yeah, we can write this also, that only solutions are 0 and pi. Now the third thing is part B. Prove the identity. Okay, we have this identity. We'll take left hand side of it. We'll take the LCM. We'll write this cos theta plus sine theta into cos theta minus sine theta. Okay, and after that, cos theta plus sine theta into cos theta minus sine theta will give you this. So sine theta into cos theta minus sine theta, you know the cross multiplication, or how do we solve the LCM? So sine theta into cos theta minus sine theta, and 1 minus cos theta into cos theta plus sine theta. So this is your first step. Next, you are going to multiply this inside, sine theta cos theta minus sine square theta, these two terms. Then 1
into cos theta, this cos theta, then 1 into sin theta, and minus cos theta into cos theta minus cos square theta, and minus cos theta into sin theta minus cos theta sin theta. This is it. Now the denominator, see, you know that a plus b into a minus b is equals to a square minus b square. So in this case, cos theta plus sin theta into cos theta minus sin theta will give you cos square theta minus sin square theta. So now simplifying some of it, these two terms will be cancelled because sin theta cos theta or cos theta sin theta both are the same things. Sorry, so these two will be cancelled. Next is you are going to take minus sign common, and this sin square theta and cos square theta when added up will add up to 1, and 1 plus cos theta plus sin theta. Sorry, minus 1, obviously. This will be sin theta plus cos theta and minus 1. Okay. In the denominator, we'll see the original equation. We get the numerator in the original form, in the required form, and in the denominator we have cos square theta minus sin square theta. That can be changed into sin square whole by using this form of the formula, that cos square theta is equals to 1 minus sin square theta. So substituting this, you will get 1 minus 2 sin square theta. This is it. I hope you'll get it. Okay. Now part C of this question. Using the results of A part 2 and B. Okay, A part 2, let's see what was A part 2. This, that only solutions are 0 and pi by 2. This is A part 2. And part B, that is the identity. We have to solve the equation. Okay, this side is equals to this, as it is clear from part B because we proved the identity. So we are writing the left side equals to sin theta plus cos theta minus 1 over 1 minus 2 sin square theta. Okay, then this is equals to this right hand side. Now solving this whole, shifting this side to your left hand side, then you can simplify it this way, that this term is common in both cos theta plus sin theta minus 1 here and here. So this will give you 1 over 1 minus 2 sin square theta minus 2. Sin theta plus cos theta minus 1 equals to 0 will give you sin theta plus cos theta equals to 1. Okay, see, here we are going to use your A part 2, where we knew that this part of the equation had the solutions only 2, 0 and pi by 2. So we are using that. We are not solving it again. We are just reusing the solution from A part 2. Okay, this part is done. Now we are going to this part. 1 over 1 minus 2 sin square theta is equals minus 2 is equals to 0. So this 2 is shifting to the other side. Then this denominator will be multiplied on the right hand side. Okay, then 1 is equals to 2 minus 4 sin square theta. 4 sin square theta is equals to 2 minus 1. See, this will move over there, 1 will move over here. So 2 minus 1 equals to 1, and 4 sin square theta will be positive then. Then sin square theta is equals to 1 over 4. And this will suggest that sin theta is equals to plus minus 1 by 2. And we know from the table that sin theta is equals to 1 by 2 when theta is equals to pi by 6. So alpha, the basic angle, will be pi by 6 or 30 degrees. Now we'll find the angle. How can we find the angle? We'll draw the grid. Pi by 6 will be all over here. The range is just in the first two quadrants, so these two will be rejected. In the first quadrant it is pi by 6, and for the second quadrant
AS. Sign is positive for first two quadrants, so we will just have the solution for this one. For the negative two ones, because it is not in our given range, so it will be rejected. Now if it is so messy, so I'm removing it. Now see, in the second quadrant the angle would be pi minus pi by 6, so it would be 5 pi by 6, 5 by 6 and 5 pi by 6. So the four solutions that we are going to have will be theta is equals to 0, pi by 2, pi by 6 and 5 pi by 6. So this is how we solve this equation. The only tricky part was the use of a part 2. Okay, the rest was just as we always do the normal normally we solve the trigonometric equations. Okay, let's start with question 8 now. The diagram shows the graph of y is equals to f of x, where the function f is defined by 3 plus 2 sine of 1 by 4x for the given range from 0 to pi, 0 to 2 pi. On the diagram above, sketch the graph of y is equals to f inverse of x. Okay, if you know that if we want to draw the inverse, first we'll draw the line y is equals to x, and this is going to be a bit difficult over here, but these points are going to be drawing. Okay, so this is your line, and next thing what are we supposed to do is that we will check the points on of this one and we will mark them on the other side. This point is just above 3 pi by 2 on y-axis and 2 pi on x-axis, so we'll reverse it at 2 pi on the y-axis and a little above from 3 pi by 2. This point, then let's consider this point is common, obviously this one between the both. Then we will be having at pi, it is just below 3 pi by 2, so here at pi just below 3 pi by 2, here somewhere. Then at pi by 2 it is here, okay, after pi. So at pi by 2 it's going to be after pi, where it is meeting the axis. Let's say this one, this is meeting just below pi at 0, so just below pi, behind pi at 0. Okay, so these are the sequence of points that we got. Now we have to just join them. I'm trying to join them with some other line. This is it, somehow like this. I hope you got it. We will see the x coordinate pi by 2 and y coordinate, okay, and we'll switch their places. This the value of x is now going to be the value of y, and the value of y is now going to be the value of x. We'll switch the values, and this is how we will get the required inverse graph. Okay, so let's move back to the next question. Find an expression for f inverse of x. Okay, fair enough. Let's first write the function f of x and f. Now we put it equals to y. Y is equals to 3 plus 2 sine 1 by 4x. Now what we do, we make x subject. So y minus 3 over 2 is equals to sine 1 by 4x. And 1 by 4x is going to be equal to sine inverse of y minus 3 over 2. Okay, and x is going to be equals to 4 of sine inverse of y minus 3 over 2. Okay, this is it. Then we will, x will be f inverse of y. F inverse of y. We put x equals to f inverse of y, and this will give you 4 sine inverse of y minus 3 over 2. And this will then become, replace y by x, so this will become f inverse of x is equals to 4 sine inverse of x minus 3 over 2. I hope you got it.
Okay, now question 8 part C. The diagram above shows the part of the graph of a function g of x is equals to 3 plus 2 sine 1 by 4x for range minus 2 pi to positive 2 pi. Okay, if you can see the graph is from 0 to 2 pi. Complete the sketch of the graph. It means that we have to complete it on the other side. It will be somehow like this. But why? Because this is a graph of a sine, and you know the sine graph is like this. Yes, if this is about 1 by 4x, so they have just given you one part of it, only this much, I guess. Okay, but we don't have to focus on this thing. Let's focus on what they have asked you. The first thing they have asked you is to complete the sketch. This is task 1, and hence explain whether the function has an inverse. So this is task 2. Okay, now let's start with the completing the sketch of the graph. Okay, for that
simply to find the values of g of x or y, because we know the function g of x or f of x, this is equals to y. So y is, you can put the values of x, these values of x, and you will find out the values of y by putting in this equation, and you will mark them over here wherever it comes. Okay, so let's start doing this. So I'm writing first here the y is equals to 3 plus 2 sine 1 by 4 x. Okay, and now add, I'm writing the values over here. Minus pi by 2, y will be equals to, you can calculate it directly from a calculator and write the values, but remember this, very important point is this, that your calculator must be in radian mode. Okay, because the values of x are given in the radians. See, pi by, the angles are pi by 2, pi, etc. Okay, so this will become 2.234. Then at minus pi, it would be 1.5857. Then at x equals to minus 3 pi by 2, we will be having it as 1.152. And at x equals to minus 2 pi, y will be equals to 1. Okay, now we have the values in points, so for the y, and here we have the values of y in pi, so we'll change this as well. Okay, like we'll write the decimal values, and so that we can plot the x and y coordinates. Okay, so 1 by 2 pi or pi by 2 will be 1.57. Let me just adjust the strength of this. 1.57, then 3.14, 4.71, 6.28. Okay, now let's plot the points. At x equals to minus pi by 2, this one, we'll be having y is equals to 2.2. So see, 1.57 and 3.1, it would be somewhere between these two values, na, 2 point
2 3. So let's plot it here, or just it would be close to, I guess, this one. Okay, now next point is at minus pi. At minus pi it is 1.58. So for here it is 1.58. So see, this is 1.57, so 1.58 would be also just above 1.58. So this one, and this next point is minus 3 by 2 pi, this one, and for that we have y is equals to 1.152. So 1.15 would be somewhere below the here. Okay, a little bit I can if manage it, then it will be, the next point is minus 2 pi, this one, and at that it is equals to 1. So 1 would be not exactly this. See, this one box here doesn't suggest 1 unit. Okay, so we'll just try to arrange this 1.15, then 1.1 should be okay. Sorry, over here, not here, just here. Now try to just join it. Okay, so this is an approximated lines in graph. Okay, that's it. So this is it. Now the second thing, explain whether the function has an inverse. Okay, what is the condition for a function, for inverse to exist for a function? If a function has an inverse, if its inverse exists, it should pass the horizontal line test. Okay, so if you draw a horizontal line anywhere, it passes the test because it is always one to one. Okay, and the function is always increasing, or you can say that it is not a many to one function. Like for the many values of x, you don't have one y. Okay, so saying this all, you can write this. You can write either any one of the reason that inverse exists because it is a one-to-one function. Okay, or not many to one, or because it is increasing and because it passes the horizontal line test. Okay, now part D. Okay, describe fully a sequence of 3 transformations which can be combined to transform the graph of y is equals to sine x for just a range from 0 to pi by 2 to the graph of y is equals to f of x, making clear the order in which the transformations are applied. So let's do this. First write f of x, and we know that f of x is given in the start of the question.
that it is 3 plus 2 sine 1 by 4x. Yes? Now next thing would be the order. The order is very important. So which transformation is applied? First you can see the sine x is changed to sine 1 by 4x. Okay, then the second transformation was sine 1 by 4x was multiplied externally 1 by 4 by 2. Then the third thing is 3 is being added to it. So this is the order of transformations, what is happening over here. Now you can explain this in words as well. 2 plus 2 sine, 3 plus 2 sine 1 by 4x. Now let's arrange them and write them up. Okay, horizontal stretch, because cx is being multiplied by 1 by 4, so stretch by a factor four in x direction, or you can say horizontally. This is the first transformation step. Now the second one. See, this function is multiplied by 2. So stretch by a factor 2 in y direction or vertically. Okay, and the third, a translation of, sorry, not 1303, sorry, you can write this in these brackets, 03. Okay, so this is the sequence of transformations. That's it. Now let's start question 9. The second term of the geometric progression is 16. Okay, so the important thing is that it is a geometric progression. Okay, now second term means, you know, a1 is equals to a, and a2 in a geometric progression is ar. So this implies that ar, the second term, is equals to 16. Let me write it a little more clear. A separate, r separate is equals to 16. Okay, and the sum to infinity is 100. Okay, if you know the formula for sum to infinity, it is sum to infinity is equals to a over 1 minus r. Okay, so this is going to be a over 1 minus r is equals to 100. So these are your two equations from the given information. Find the two possible values of the first term. Okay, if you want to find the two possible values of a, so that means we are going to take this r and substitute it in equation 2, so that we can eliminate this r and then we get the equation in a. So let's do this. So equation 1 implies r is equals to 16 over a, and equation 2 implies now a over 1 minus 16 over a is equals to 100. Okay, then simplify this. A square is equals to 100 into a minus 16. So a square minus 100a, and skipping one step, first you'll multiply 100 with a and minus 16, and then you'll bring everything on the left hand side. So a square minus 100a minus, it will be 1600, so on the other side it would become plus 1600. Now let's find out a. You can break the middle term. So two numbers that when multiplied give you 1600, and when added or subtracted will give you minus 100. Obviously it would be 80a minus of two terms, so that they multiplied will give you positive, and when added with a minus sign they will give you 100. So minus 80 minus 20 a plus 1600 equals to 0. Okay, yeah, a minus 80 minus 20 is a minus 80. So this will give you a minus 20 into a minus 80 equals to 0. This implies a is equals to 20 and a is equals to 80. That's it. So these are the two possible values of the first term. Now part B. Show that the nth term of one of the two possible geometric progressions is equal to the 4n minus 2 multiplied by nth term of the other geometric progression. Okay, So we have a is equals to 20 and a is equals to 80. And also for the nth term we'll be needing r. So we know that ar is equals to 16, or r is equals to 16 over a. So r will also be different for both of them. R is equals to now let's write the nth term for both. A r n minus 1. So 1 will be 20, r will be 16 by 20 will be 4 by 5, or 1 by 5. Yeah, okay, so this will give you 1 by 5. So first write up for the a equals to 20, so it will be 4 by 5 and minus 1. The second would be n is equals to 80 times 1 by 5 n minus 1. Okay, so they are telling you that one of the two possible geometric progressions is equal to 4n minus 2 multiplied by nth term. So it will be true for in only one case. Either this multiplied by 4n minus 2 will be equals to this one, or this side multiplied by 4n minus 2 will be equals to this one. Okay, so we have to check this by doing it, or there is another method as well, but for now I am doing this, making this equals to 80 times 1 by 5 n minus 1 multiplied by 4n minus 2 will be equals to 20 times. Okay, now solve it and see if you get the other one. If not true, then we'll take the other equation, this one, and we'll multiply it by 4n minus 2 to check if it comes equals to the second one. Okay, so this will give you 80 1 by 5 n minus 1 4. Distribute the powers of 4 power n and 4 power minus 2. Okay, and then you will be getting 4 power n over 4 power 2. So this will give you 80 by 16, as we have 4 square, and this will become No, we won't do it, because actually in the second term also we are having n minus 1 on the whole. So try doing that, try making it this way. So it will become, what if we take 1 4 over here and 1 by 5 n minus 1 and 4 power n and 4 power minus 1, because 1 was left over here and when it moves to the numerator it will become 4 power minus 1. So 4 2s are 8, so this becomes 20. 1 by 5 n minus 1 and 4 power n minus 1. So if both have the same powers we can write them together. So it will be 4 by 5 power n minus 1. Okay, so that's it. This is all about your part B. Yeah, okay. This way it comes correct, but even if you have started the other way, you'll get that it is not working, so you'll come back to this way and you'll get if the two terms will be equal in this way, like multiplied by 4n minus 2, one of the terms. So this is how it will get proved. Otherwise you can do this. I'm not showing you the whole process, but obviously see if there is one term multiplied by 4n minus 2 and this will equals to the other term b, for example. So the one thing you can do is, one, you can do a over b, and if it will come sorry, not a over b, if you will do b over a, like you can divide two of the terms and then you will be getting 4n minus 2, and in this way also it can be proved that you divide the two of the terms. And again in that way also you have to check the both ways, that which will come in the numerator and which will come in the denominator. So you are going to get the 4n minus 2. So you'll divide the both, and if you get 4n minus 2, so obviously this means that the one term multiplied by 4n minus 2 is equals to the second term. I hope you get it. So that's it. Now let's move on to the next. Okay, question 10 now. The equation of a circle is x minus a whole square plus y minus 3 whole square is equals to 20. The line y is equals to half x plus 6 is a tangent to the circle at point P. Okay, so first make a circle, make a line, or for instance this is a tangent at point P. Show that one possible value of a is 4 and the other possible value, and find the other possible value. Okay, so if we have a one point of intersection between a curve and a line, so we know that our gradient, or b square minus 4ac, is equals to 0. Okay, but before that we have equation of a circle and the equation of a line. So what we will do is we are going to substitute the equation of line in the equation of circle, and in this way we will get the point of intersection, or we'll get equation. See, in this case we have a, not a number, so we won't get the points of intersection. We'll get some equation in a and then we'll solve it out to get the possible values of a. So let's start. X minus a whole square plus y minus 3 whole square is equals to 20. We are going to substitute the value of y in it. So I am doing in the same step. Half x plus 6 minus 3 whole square is equals to 20. So now expanding this, x square plus a square minus 2xa
plus, first arrange this a bit, half x plus 3 whole square is equals to 20. Then it will be x square plus a square minus 2xa plus 1 by 4x square plus 9 plus 3x. Obviously 2 and 2 will be cancelled, so 3x is equals to 20, or you can do minus 20 equals to 0. Okay, then x square plus 1 by 4x square would be 5 by 4x square. Okay, and then plus a square minus 2xa and this minus 11 equals to 0. So we skip this one, so here it will be plus 3x as well. Minus 2xa minus 20. Okay, sorry, so I told that it would be an equation in A, but it is going to be a quadratic equation in X. Okay, so this will be 5 by 4x square. Then the x term will be combined plus 3 minus 2ax plus a square minus 20 is equals to 0. Okay, now as I said in the start that now we can apply b square minus 4 is equals to 0 because we have just one point of intersection. So it will become 3 minus 2a whole square minus 4 times a c equals to 0. Expand this, 9 plus 4a square minus 12a. 4 and 4 will be cancelled out, minus 5 times a square minus 20. Okay, we can do directly as well. 5a square plus 5 to the 10, so it's going to be 100 equals to 0. Then we will be having minus a square minus 12a plus 109, and we can multiply this whole equation by minus a square plus 12a minus 109. Okay, so now we added here a bit, I guess, because it is not giving us any roots. See, here it was minus 20 and plus 9, so when we rewrite it in the next line, we added, it is going to be different, and it's going to be minus 11 a square minus 11 over here, and then 5 times 11 will be minus 55, and then plus 55
plus 9 would be 64. Okay, now it can be like middle term can be broken. It would be a square plus 16a minus 4a minus 64 equals to 0. So this will give us into a plus 16 minus 4 times a plus 16 equals to 0. A minus 4 times a plus 16 equals to 0. So this implies a is equals to 4 or a equals to minus 16. Okay, so this is it. They here you also showed that a is equals to 4 is one value, and the other possible value is a equals to minus 16. Okay, for a equals to 4, find the equation of normal to the circle at P. Okay, now just take this. Okay, and for a equals to 4, find the equation of normal to the circle at P. Okay, now what will be the normal will look like? If you draw P, write P over here, normal will be like this. Okay, so let's first write down the two equations. Y is equals to half x plus 6. So we need these two. Okay, so to find the equation of normal, what do we need? We need one point, and that can be the center of the circle, and the gradient. That will be the negative reciprocal of the gradient of your tangent line. Okay, so first we know that a is equals to 4, so we'll substitute that. Now start doing it. First is slope of the tangent is 1 by 2, as evident from here, from the equation of the tangent, and slope of normal is going to be minus 2. One thing. Second is what will be the point center is evident from the equation of the circle. It's 4 and 3. So the equation of normal would be y minus y1 is equals to m times x minus x1. So substitute the values. Y coordinate is 3, m is minus 2, and x is 4. So this will be your equation of normal. Okay, so now part C. For a equals to 4, find the equation of the two tangents of the circle which are parallel to the normal found in B. Okay, now consider your figure again. Okay, and try to understand what they are saying now. Two tangents to the circle which are parallel to the normal. Okay, so these would be this and this. Okay, these will be two tangents and these will be parallel to the normal. Okay, for that, what do we need? Understand this. We need the slope of these tangents, which if are parallel to normal, so it will be same, because for the parallel lines the slope is equal. Okay, so these would be same. The second thing that we need is one point for each equation of tangent. So we need this point and we need this point. Okay, so to find out these 2 points, we can do one thing, that we can find out an equation of the diameter. Okay, and if we equate it with the equation of circle, so we'll get the point of intersection. So in this way we'll be getting the points. Okay, so let's start. First tell me what is the gradient of the normal. -2. So this is will be equals to -2. Now points of intersection. Okay, so for that we first need equation of diameter. We can find the equation of diameter. How? We have a point that is center, that was 4 and 3, and the slope was the parallel to the slope of this tangent line that was originally given. So that slope will be 1/2. Let me just check it from above. Yeah, center is 4, 3 and slope is 1/2. So find out the equation of the diameter. Y minus 3 is equals to half x minus 4. This is your equation of the diameter. Now arrange this a bit. 2y minus 6, we are multiplying this 2 on the other side, is equals to x minus 4 2y is equals to x plus 2. Okay, and from here we can get y is equals to x plus 2 over 2. Why I'm getting this in the y form? Because we have to equate it with the equation of the circle, and for the equation of the circle, and then we have to like we can't, in the equation of the circle we can equate, we actually have to put the value, put the equation of y in it. So let's arrange everything a bit. This was x minus 4. Okay, so let's do this. X minus 4 whole square plus y is x plus 2 by 2 whole square. Sorry, not this whole square. Y minus 3 whole square is equals to 20. So this will become x square plus 16 minus 8x. So the other side will become x by 2 plus 1 minus 3. See, if we distribute this 2 with both the numerators, so minus 3 plus 1 will be minus 2. So I am rightly writing it minus 2 whole square is equals to 20. Okay, then expand this further. X square plus 16 minus 8x plus x square by 4 plus 4 minus 2ab, so 2 and 2 will be cancelled out. And we will be having 2x, okay, and minus 20 equals to 0. Next point would be x square plus x square by 4. So directly doing this will become 5x square by 4 minus 10x plus 20 minus 20 would be equals to 0. This seems like 16 instead of 10. Okay, and see, 16 plus 4 20, and this minus 20, this all will be cancelled out and will become 0. So this is going to be equals to 0. So then we will be having, if we'll take x common, so it will be 5 by 4 x minus 10. So this implies, okay, now this implies either x is equals to 0 or 5 by 4 x minus 10 equals to 0. Or x is equals to 10 into 4 by 5. So this will become 5 to the 10, 4 to the 8. So solving this all will give you x equals to 8. So these are the two values of x. From these two values of x we can find the two values of y. Again we need some arrangement because this is a lengthy question. You can always take an extra sheet for the working that you will be having. Okay, and then we will be having this. Now we have to find the y because we need 2 points of intersection. Actually we need to shift this one as well I'm shifting it upwards because we need a lot more working. Where is y? This is your equation of y. No? So here you are going to substitute to find the y coordinate. So x equals to 0 will give you y is equals to 1, and x equals to 8 will give you 8 plus 2 by 2, 10 by 2, 5. So you'll be having 2 points, 0 and 1, and 8 and 5. Okay, and now equations of tangent 1 would be y minus 1 is equals to slope or gradient is minus 2, x minus 0, and the second one would be y minus 5 is equals to minus 2 times x minus 8. So these are your two equations. You can either simplify them as well. This will become y minus 1 is equals to minus 2x. Equation of tangent 2 would be y minus 5. This is it. This is your whole working. Okay, so now question 11. Equation of a curve is this: y is equals to k times under root 4x plus 1 minus x plus 5, where k is a positive constant. Find dy by dx. Okay, so you know y is equals to k times 4x plus 1, 1 by 2 minus x plus 5. So dy by dx would be 1 by 2 times k as it is, and 1 by 2 I am just combining 1 by 2 and k, so it will be k by 2, 4x plus 1, and minus 1 would be minus 1 by 2, and multiplied by the bracket, derivative of the bracket, that would be 4 minus 1. The derivative of x would be 1, and the derivative of 5 would be 0, so we are not writing that. Okay, so now it's going to be 2k 4x plus 1 minus 1 by 2 minus 1. This is our derivative. Okay, or you can write it in the fraction form: 2k over 4x plus 1 under the root. Minus 1. Now find the x coordinate of the stationary point in terms of k. Okay, we know that for the stationary point dy by dx is equals to 0. So this is your dy by dx. So we are substituting, putting it equals to 0. So this will become 2k over 4x plus 1 equals to 1. 2k equals 4x plus 1, squaring both sides. 4 square is equals to 4x plus 1. And we have to tell the x coordinate in terms of k, so taking out x, 4x, keeping 4x over here, and this will become 4k square minus 1. X will be 4k square minus 1 over 4. Okay, or you can write it x equals to 1 by 4, 4k square minus 1, or k square minus 1 by 4, whatever way you can arrange it, it's not a big issue. Okay, so this is it. Now part C. Given that k is equals to 10.5, find the equation of the normal to the curve at point where the tangent to the curve makes an angle of tan inverse of 2 with the positive x-axis. Okay, this is a tricky part. So for instance, think of it as that this is your curve and this is your line. Here we are talking about a normal, a tangent and a curve. So equation of normal is what we need to find. So it must be any line like this. Okay, at a point where the tangent to the curve it makes an angle of this, where the tangent, this is your tangent, makes the angle of tan inverse of 2. Okay, so if you know that dy by dx is your gradient, okay, and it is equals to the, also equals to the tan theta. See, I'll explain it with the help of an example. If you take any triangle, so perpendicular over base, or you call it as opposite over adjacent. Okay, so this is equals to tan theta. Yes, and also the slope is also the change in y over change in x. So this is the same thing. Okay, so these both things tell you if you have the derivative of any line, then it is its gradient or slope, and if you know the tan theta, it is also means the same. Okay, so that is equals to, as theta is equals to tan inverse of 2, so that means tan theta is equals to 2. Okay, and also I'm writing this over above here. Now write the equation that is already given. This is your equation. So first thing we'll do is, we know the dy by dx. We know dy by dx. This is equals to tan theta, and tan theta is equals to 2. So first take your dy by dx. This is your dy by dx. Okay, so this is equals to 2, as we know that this is equals to tan theta, so 2 equals 2k over under 4x plus 1 minus 1. So this will give you 3. Okay, sorry, we have to substitute the k equals to 10.5 as well. Okay, that is important. 2 into 10.5 is 21. So solving it for x now, so this one on the other side will give 2 plus 1 3, 21 over square root of 4x plus 1. So this will give you x plus 1 equals to 7. We cross multiplied it and simplified this 3 into 21. So squaring both sides will give you 4x plus 1 equals to 49, and then x equals to 48 divided by 4, then x will be equals to 12. So this is your x. Now substituting this in your equation of y, and we'll get the y. So taking it, here one more thing is we haven't substituted 10.5, so we will do that. Okay, and putting x equals to 12. Solving this all with a calculator, it is 66.5. Now we got x and y coordinates for the point of intersection, or the point at which we have the tangent and the normal. So now by using this point and the gradient, we will find out the equation of the normal. But what is this gradient dy by dx that we just found? This one that we said that dy by dx equals to 2. This is the gradient of the tangent, because this tangent was at an angle and this was the gradient of the tangent. If we have the gradient of the tangent as 2, which we write over here, so the gradient of normal would be minus 1 by 2, because it is going to be the negative reciprocal. So 12 and 66.5 is the point, and the gradient is going to be minus 1 by 2. So writing the equation of normal, y minus 66.5 is equals to minus 1 by 2 x minus 12. You don't need to simplify it further. This is completely okay. this just seems a bit off. Okay, now it says a bit. That's it. Okay, this is all about your paper 1, May June 2023. Some parts were a bit difficult, but overall it was okay. So that's all. Thank you. Allah Hafiz.